In this video, we create the user interface of our macro module and add Python scripting for user interaction. Search for your macro module and add it to your workspace. Right-click and select your script file. The MeVisLab text editor made opens. Add a window section to your script file. Inside the window, we need a vertical for the 4 parts and a box for each part. Name the boxes Source, Viewing, Settings, and Info. The layout inside each box shall be horizontal. You can preview your initial layout in MeVisLab by double-clicking your module. Add a field to the parameters section of your script file. Name the field Open File and set type to string and internal name to local image.name. Add another field to your box for the source and use the field name from Parameters section, in this case Open File. Set Browse button to true and Browse mode to open and save your script. Again, you can preview your user interface in MeVisLab directly. You can already select a file to open. The image is available at the output of the local image module in your internal network, but the viewers are missing in our interface. Add the tviewer modules to the viewing section of your script file and define their field as view2d.self and SoExaminerViewer.self. Set the 2D viewer type to SoRenderArea and the 3D viewer type to SoExaminerViewer and inspect your new user interface in MeVisLab. Both viewers can be used in the viewing section of your module. In order to define the color of the segmentation overlay, add another field to your parameters section as Select Overlay Color. Define internal name to SoView2D Overlay Base Color and type to Color. Add the field to the settings box and set title to Color. For the rest of our settings, we need 3 more fields in the parameters section of the script. Add the fields Image Alpha, Threshold Interval and ISO Value Image to the section. Use internal name SoWemRenderer Image.Face Alpha Value, Region Growing. Auto Threshold Interval Size in % and ISO Surface Image.ISO Value and define type integer for all of them. We define reasonable min and max values and add all 3 fields to the settings box of our macro module window. Set slider to true and define a reasonable step size for each of the fields. Opening the window of our module now shows a color selection and 3 sliders for defining image alpha, threshold and ISO value of the image. You can change them and inspect the changes on your segmentation. For the next elements, we require Python scripting. Add another field to your parameters section. Define the field as selected 3D view. Set type to enum and values to segmented, file, and both. Add a combo box to your settings and use the field name defined above. Set align X to left and editable to false and open the window of the macro module in MeVisLab. The values of the field can be selected, but nothing happens in our viewers. We need to implement a field listener in Python which reacts on any value changes of the field selected 3D view. Add a field listener to the commands section and reuse the name of our internal field selected 3D view. Add a command to the field listener calling a Python function ViewSelectionChanged. Right-click the command and select Create Python function ViewSelectionChanged. We are defining the So switch to use the input depending on the selected value of the user. Add another field marker position to the parameters section and define type as vector3. Then, add a trigger field apply marker to your parameters section. Set type to trigger and title to add. Add field listener commands insert and apply position to the new fields. The insert position function sets the field SoView2D marker editor.newPosXYZ to the value of the marker position field. The apply position function adds the given value to the SoView2D marker editor module and updates the marker location for the region growing. Finally, we want to add a reset functionality to reset the application into its default state. Add a new field reset application to the parameters section and set type to trigger and title to reset. Add another field listener to your commands and define command as reset application. Add the field to your source region. The reset application function shall delete all markers, clear the region growing segmentation, close the loaded image and sets all sliders to reasonable default values. You can also reset the application to initial state by adding a init command to your window. Call the reset application function here, too. Whenever the window is opened, the application is reset to its initial state. The volume of the segmentation in milliliter shall be shown in the info section of the window. Add one more field to your parameters section and reuse the internal network fields. Calculate volume. Total volume. Set editable to false. Add the field to the info section of your window. Your macro module now provides a user interface with Python scripting, and we have a running prototype in MeVisLab SDK. For further information, please have a look at www.mevislab.de.